This is number 78 in chapter 2. It talks about isotopes as far as naturally occurring isotopes and then how that relates to the average mass that we see for elements. We have to remember that the elements, as they are shown on the periodic table, have multiple isotopes. And the atomic mass that we see on the periodic table is actually an average of those isotopes and their natural abundance. And so 78 is looking at silicon. Silicon has 3 naturally occurring isotopes. It has silicon 28 and 29 and 30. Those are designating different masses as a result of having different neutrons. The number of protons are all the same. That's what identifies it as silicon, but the number of neutrons must be different so that we have multiple isotopes of silicon. And so if we look at this, they give us some more information. The mass and natural abundance of Si-28 is 27.9769, and its abundance is 92.2%. For silicon 29, the atomic mass was 28.9765, and its abundance was 4.67%. And the question is asking us to find the mass and natural abundance of silicon 30. So what are those two guys? So to begin, we have to know what the equation is for isotopes and how they relate to average periodic mass. So the mass that we see on the periodic table is an average of these isotopes and their natural abundance. So that is really equal to the sum of the isotope mass times its fraction, or its fractional abundance, its percentage, essentially. So if we set this up, you would have your silicon from the periodic table is going to be equal to Si-28 times its fraction plus Si-29 times its fraction plus Si-30 and its fraction. And so we start to plug these values in. If we go to the periodic table, we see that silicon has a mass of 28.09. And so that would equal our silicon 28 mass, which is 27.9769 times its fraction. And remember, a percentage is just a fraction, but we won't want to use the 92.2. We want to turn that into a fraction, or 0.922. We're going to add that to our silicon 29, which has the mass of 28.9765, times its percentage, which is 0.046. I'm sorry, I'm running out of room here, so I'm just going to write this a little bit below. We're trying to determine the mass of the silicon 30 isotope, but we do know its fraction, right? We only have 3 isotopes, and so they should add up to equal 100. And so if we take 100 minus those 2 percentages, we're left with 3.2% left over, and so that is its fraction. And so if we do the mathematics here, I'll do it stepwise. We take the first product, we get 25.795. We take the second product, we get 1.333. And for the third, that's actually what we're trying to determine. So if we bring these guys to the other side of the equal sign, we get 0.962. And so that would be equal to our SI 30 times its fraction, or its natural abundance. And then when we do the math, we get a atomic mass of this isotope of silicon to be equal to 30.063. So we just have to remember that when we're looking at the periodic table, the mass that we see for an element is really an average mass. It's an average mass of all the isotopes that are naturally occurring for that element, as well as those specific isotopes' natural abundance.